Good morning, Jim. Your project is a 4-output switching power supply. The input voltage range is 3 volts to 42 volts. It must be short circuit protected, have low operating IQ, and meet CISPR 25 EMI requirements. You have 5 square centimeters. Good luck, Jim. Hi, I'm Mike Nootbaar, Senior Design Engineer for Power Products at Linear Technology. Do you sometimes feel that this is the way power supply projects are assigned? Frequently, the power supply simply gets whatever board space is left over, no matter how impossibly small. Here, using Linear's latest quad buck regulator, the LT8602, I will show how you can have 4 regulated outputs in an incredibly small space. The LT8602 has 2 high voltage buck regulators with an input voltage range of 3 volts to 42 volts. It also has 2 low voltage buck regulators with an input voltage range of 2.5 to 5.5 volts. The high voltage regulators provide output currents of 1.5 amps and 2.5 amps. Both low voltage regulators provide up to 1.8 amps of output current. Let's look at the 8602 in a lab setting. The LT8602 demo board is set up with DVMs monitoring VIN, IN, and all 4 Vouts. These are all the components necessary for 4 buck regulators using the LT8602. There are no components on the back side of the board. This complete solution occupies only 4 square centimeters of board area. We're monitoring the input voltage and output voltages 1, 2, 3, and 4. Watch the outputs as I step the input voltage up to 42 volts. The output's hardly changed at all. Now I'll drop the input voltage to 5.5 volts. Still, very little change on the output. Ramping the input down, we see that the dropout on the 5-volt output is very small. Let's go back to 12 volts and add an input current monitor. With 12 volts input and no load, only 30 microamps holds up all 4 supplies when in burst mode. Adding a 100 microamp load to the 3.3 volt output only adds 30 microamps to the input draw. That's an incremental efficiency of 92% at very light load. Oops, for mini switching regulators, that accident would destroy the part. Not so with the LT8602. An oscilloscope monitors inductor current. The LT8602 has both peak and valley current limiters to protect against non-shorting overcurrent conditions, as well as direct shorts to ground. Here we're monitoring inductor current. Shorting channel 1 output to ground results in a dramatic drop in operating frequency and the inductor current limiting at a safe value. The other channels are not affected. Release the short and the output returns to normal. The low voltage channels operate similarly. Now I'll short channel 3 output to ground. Once again, the frequency drops and the inductor current is limited. Release the short and the output returns. It will also protect against inductor shorts. This jumper will short the inductor on channel 1 while we still monitor the output voltage and inductor current. You can see that the shorted inductor current is limited and the output remains in regulation. The other channels are unaffected. Remove the short and the inductor current returns to normal. While the LT8602 is small and efficient, it also provides impressive EMI performance with careful PC board design. The LT8602 demo board is an excellent example of good PC board design. Each PVN pin has a decoupling capacitor placed on the same side and as close as possible to the LT8602. An unbroken ground plane occupies the second copper layer, providing a short, high-frequency return path. Additional components on the back of the board improve conducted EMI while occupying less than 1 square centimeter of board area. These are the independent lab results for the radiated emission of our demo board. As you can see, the LT8602 easily passes CISPR 25 Class 5 limits in both horizontal and vertical polarizations. Check out linear.com and see how we can turn your project impossible into reality.